All right, that would be good. Okay, so we are doing number 18 in section 4.8. Okay, here we go. I know it's Friday and everybody's all excited, but we are probably going to have a test next week. Well, we are going to have a test next week, and we need to get ready for that. So, 18, here we go. We have a ship traveling at a speed of 40 knots. Knots, remember, are nautical miles per hour. Knots is nothing more than a speed. It's a speed. 40 nautical miles per hour. So, here's Fort Lauderdale right here, and I'm setting up a compass point because they're giving me a heading, okay? They're telling me on a course of 65 degrees. Now remember, on the compass, that's 0 and that's 90, so 65 degrees is going out here like this. Okay, so he's traveling on a course of 65 degrees at a speed of 40 nautical miles per hour for 2 hours. So the length of this is 80. He's going 2 hours at 80 or 40 miles an hour. All right, then he changes course. So I'm going to put another compass point here. And he changes course. And now he's on a course of 155. Well, remember, this is 90 and this is 180. So 155 would be like this. For 4 hours. So that one's going to be a little bit longer, right? And he's still going the same speed, so this would be 160 miles. He's going 40 miles an hour for 4 hours. So now the boat is here. And this angle was 155 degrees. So the question is, determine the distance and the bearing from Fort Lauderdale to the boat. So the question is, how long is that? How long is that? And what is this angle right here? The big purple angle. Now, would you agree that whatever the big purple is, it's 65 plus the angle that's in the triangle? So if I could find the angle in the triangle, I'll just add 65 and that will be his bearing. And now somehow I need to find x. Now, we can't just jump in and do the Pythagorean theorem until we figure out if this is a 90-degree angle or not, right? I'm hoping it is, but I have to figure that out. And that's easy to do. That is very easy to do. There's a lot of lines going on, but think about these two north-south lines. They are parallel, right? When you draw that guy right there in, that's a transversal. This angle, which is 65, is going to the alternate interior with that one. Would you agree with me? These are parallel lines cut by a transversal. Now, this is 155, which means this part of it right here is 25, because that would be 180, the whole thing. What's 65 plus 25? So there it is. There's your right angle. Now, in the next chapter, they won't be right angles, and that's why we have other tools besides the Pythagorean theorem available to us. But thank goodness that's a right angle. So now I can do the Pythagorean theorem and find x. So that is just going to be whatever the square root of 80 squared plus 160 squared is. So you can type that in and figure that out. That's how far we are from Fort Lauderdale. Now I need this angle right here. We said we're going to take 65 and add this one. I'll call it theta. Now that's a right triangle. Which side is this? Opposite, adjacent, hypotenuse? Opposite. I'm talking about this angle now. So this would be opposite, and this would be adjacent. So can I say tan theta equals 160 over 80, or tan theta equals 2? And then what buttons do I press on my calculator to find the angle? I'm looking for the angle. So I don't use the tangent button, I use the second tangent button. So second tangent 2 will give me this angle right here, Taylor. And then I'll add it to 65, and that will be the course that we are on. Okay? Those pictures get a little bit cluttered, unfortunately, but every time you change direction, you should set up your little compass so that you can see how big all those different angles are. Okay? All right, any other things you want to talk about before we jump in and finish, hopefully, this massive review sheet? All right, I believe yesterday we stopped and we are now ready. I think this is review sheet 4, the big one, the longest one, and we are ready for 9C, which is find amplitude, period, phase shift, vertical shift, and frequency for the and sketch the equation y equals tan x. Well, it doesn't get any easier than that. There's no changes to the curve. It's just the regular tangent. So you need to remember what the regular tangent looks like. Do you remember it has an asymptote here and an asymptote here and a squiggly line in between like that? That's your tangent. That was on your memorization sheet. That needs to be memorized if it's not already. Where are the asymptotes for the regular tangent? Negative half pi and positive half pi. Problem number 9C is just the regular tangent. There aren't any numbers stuck in it. We haven't changed anything. All right, what's the amplitude of this tangent or any tangent? None. No amplitude. No ceiling, no floor, no amplitude. What's the period? What's this distance right here? Pi. Now that is a significant difference from the sine and cosine, because what's the period of the sine and cosine? 2 pi. Now that means that if we had stuck a number in here, let's say I did stick a number in there, to find the period, you wouldn't do 2 pi divided by 2, you would do just pi divided by 2, because the standard normal period of the tangent is pi. So if you put any modification, it's going to change pi, not 2 pi. And obviously we didn't stick any numbers in, so we have frequency, phase shift and vertical shift. We don't have any of that because we didn't stick any numbers in. And our frequency would be what? If our period's pi, our frequency is 1 over pi. Once we get through this sheet, we can graph another tangent. There are other ones on these other sheets that have some changes. But let's get through this sheet first. Okay, number 10. We want to find the area of the shaded sector. All right, the angle is 100 degrees and the radius is 6. Now we are finding the area. Now I know when I see that picture, I think radius times radians. Hopefully maybe you do too. But what's that? Radius times radians is going to give me the arc length, and this isn't about arc length. This is about area. So how did we do this? Do you remember? It's real simple. Find the area of the whole circle, which would be 36 pi r squared, area of the whole circle. And then we don't want the whole area, right? That's the whole area. We want a fraction of the whole area, right? What fraction do we want? 100 3/60ths of 36 pi, right? The whole thing is 360. We want 100 of those 3/60ths. So 36 and 36 are going to cancel. Oh, I think this one works out nice. Is it just 10 pi?
Unit squared.
Yes. Unit squared. Very good. Do I have units here? No, I'll make some up. Centimeters, so this would be centimeters squared. Evaluate on the calculator. All right, let's get our calculators out. Now, if there is a section like this on the test, my recommendation to you is, see how some of them are in radians and some of them are in degrees? Pick one and go through and do all those problems, and then switch the calculator and go through and do the rest. Otherwise, you're going to be switching back and forth problem to problem, and you might forget and mess up. So the very first one is in radians. So I'm going to set my calculator in radians. So I go to mode and highlight radians. Everybody good? So now I'm just going to type sine 2.3. 0.7457. And we'll round however it tells us on the test to round. Everybody good? 0.7457. All right. Now the next radian question is C. So I'm going to skip down to C now, and I'm going to do tangent pi divided by 7. 0.4816. I'm going to assume if I don't hear from you that you're getting it. Same thing. All right, the next radian one is E. Oh, shoot. I don't have a secant button. How do I do that on my calculator? I don't have a secant button. 1 divided by cosine. I have to literally type 1 divided by cosine 8 pi over 9. 1 divided by cosine 8 pi divided by 9. I got negative 1.0642. Remember, if you don't have that button, you got to do 1 divided by.
What did you get?
All right, now all the radian problems are done. So now I'm going to go back into my calculator and I'm going to change my mode into degrees. And now I'm going to do the degree problems. Where am I? Cosine. All right, everybody remember how to do 12 degrees 11 minutes? Cosine. 12 second angle degrees, 11 second angle minutes, 0.9775. 0.9775 is what I got for D. Cotangent 10. No cotangent button. So what am I going to type? 1 divided by tangent 10. 1 divided by tangent 10. I got, 5.6713. Patty, you got a calculator, sweetie?
I know.
You love pressing buttons. Get that out. Let's press these buttons. And then the last one, F. That's a big one. Got all the stuff going on, but it's also a cosecant. Can't do a cosecant on my calculator. I mean, I don't have that button. So what am I going to do? 1 divided by sine 18, 11, 19. So here we go. 1 divided by sine 18 second angle degrees, 11 second angle minutes, and then 19, remember the weirdness here, alpha plus, enter, I got 3.2036. All right, so we good on that? Just typing stuff in on our calculator. All right, part 12. Did we do either one of these yesterday?
No.
Nope. All right, we're going to do them both right now then. Number 12, we're going to write the equation of this first thing. Now note the directions. Write two equations. What that means is, I know it's not very clear, so I'm just telling you. What that means is I want a sine equation and a cosine equation. All right, so when we write these equations, we have 4 places that we can stick in numbers. Remember that? Because we have amplitude, period, phase shift, and vertical shift. And all those are numbers that would go into the problem. The good news is that as I go from sine to cosine or vice versa, most of those blanks stay the same. So it's not like I have to do 2 completely different problems. All right, so you look at that, what do you see? Sine or cosine, what do you see? Well, I see a sine curve, so I'm going to start with this equation. Do you see a sine curve there? So I'm going to start with this equation, and 4 is the amplitude, and that would be a positive 4 because with a sine curve, you're supposed to have the hill and then the valley. If you have the valley and then the hill, it's upside down, and you would need a negative. We don't have that, so we have a positive 4. All right, what do you notice about its starting point? It's right where it's supposed to be, right? Which means what have we not done? We haven't shifted it, so that's going to be a 0 there. Notice it's going up 4 and down 4, which means it's situated right on the axis, so we haven't lifted it up either, right? The tricky one, or the one that I do some work on, is this guy right here. I need to know what that coefficient is. But that's easy, because you know, you've done it a million times. Period is 2 pi divided by that coefficient. That's how you find the period of a sine curve. Well, what do we know our period is? 4 pi over 3. So 4 pi over 3 is what we get when we take 2 pi and divide it by that coefficient. So we need to figure out what that coefficient is. It looks like that coefficient is 3/2. I'm perfectly okay with you writing the equation this way, but actually that one could be written as just this. Would you agree with me? So if you would rather kind of clean it up and write that, that's fine. This is also fine.
If we put the pi, would you count wrong? Oh, it can't go down.
Now, cosine. If this is a cosine curve, it has exactly the same amplitude, it has exactly the same period, and it has exactly the same phase or vertical shift. The only thing that's different is, if you're going to look at that as a cosine, then you're going to start looking here and stop looking here, right? It's the same curve. Fundamentally, it's exactly the same. These don't change. The only thing that changes is, instead of starting at 0, you're now starting at pi over 3, which means you have shifted things over. You've shifted them over pi over 3. So in your equation is going to be x plus or minus pi over 3, because we shifted to the right. And that would be your equation for your cosine. Now, there are other equations you could write too, but those are probably the main ones that you would think of to write. All right, let's look at the next one. Same directions. So I'm gonna write my equations. Got some numbers to put in. Alright, so let's start filling in the numbers. Now, obviously, this guy has been shifted up. So you might want to put in the new axis. Would you agree that's the new axis? The picture's been picked up and now it's oscillating up there. Now how much did I pick it up then? 4. I picked it up 4 because the axis was at 0, right? And now the axis is up at 4. So your vertical shift is going to be 4. That picture has been picked up 4. What's the amplitude? How high are the hills and valleys? 2. So the amplitude's 2. Now, you need to pick a chunk of that to look at because you got to figure out what the period is. So, are you thinking about that as a sine or a cosine? Doesn't matter. There's no wrong answer. We just need to start. So, are you thinking of that as a sine or a cosine? Sine? I'm thinking of it as a sine. I'm looking at this right here. Personally, are you looking at maybe this right here? You like the black one better? The black one's right side up. And the black one is starting exactly where it's supposed to start. So if we look at the black one, forget my purple one, if we look at the black one, then we're starting right where we're supposed to start. And our period is how much? How much is our period? Starting at this black dot and going to this black dot. How far is it? 4 pi over 8, which I'm going to go ahead and reduce to pi over 2. So the period is pi over 2. And we know that period is found by taking 2 pi and dividing it by that coefficient. So what does that coefficient have to be? 4. So this coefficient is a 4, which means this coefficient is a 4. Only thing we have to do now is figure out what cosine curve we're going to look at. Could you start here and stop here for a cosine curve? And if you did that, remember cosines start at the top of the hill. They go from hill to hill or valley to valley. If you did that, what would your phase shift be? Pi over 8. So that would be your equation if you went from x to x, if that's the cosine curve that you looked at. Easy enough? Maybe not easy, but manageable. 13's easy. Find 2 angles coterminal with negative 21. How do we find coterminal angles? Add or subtract a revolution. This is a degree measure, so we're going to add 360 and get what? 339. And then we'll subtract 360, negative 381. Coterminal angles, we add or subtract 360 if we're in degrees. Now look at 14. We are not in degrees, we are in radians. So we are not going to add or subtract 360. What are we going to add or subtract? 2 pi. It's a revolution. So you're going to have pi over 7 plus 2 pi and pi over 7 minus 2 pi. Now some of us make this way harder than it is. This is arithmetic. Get a common denominator and add and subtract. So pi over 7 plus 2 pi over 1. My common denominator would be 7. So pi over 7 plus 14 pi over 7 is 15 pi over 7. And then do the same thing here, only subtract, and that would be negative 13 pi over 7. So your coterminal angles are 15 pi over 7 and negative 13 pi over 7. Got it? All right, 15. In which quadrant is theta if the sine is negative? That's what this means. The sine is negative and the cosine is positive. Quadrant 4. Who said that? Why? What are you thinking? What's your thought process? You are right, by the way, but what's your thought process?
Cosine to x-axis, sine to y.
Exactly. That's the key, kids. You got to remember cosine is x, sine is y. So basically what this question is saying is, where is it that y is negative, but x is positive? Where does that happen? Quadrant 4. The answer is quadrant 4. That's where y is negative. This is y, sine is y, cosine is x. Now, when I say sine is y, I'm going back to the definition. Sine is y over r. R is always positive, so it's a non-factor. The sign of the sine, the S-I-G-N of the S-I-N-E, depends on y. And cosine depends on x. Easy. Name a quadrantal angle. 270, 180, 90, 0, 360, negative 90, negative pi. Quadrantal angles are angles that are on the axes, right? Easy. Solve for x, no calculator, and we're between, that actually should be this. We're between 0 and 360, and we want the sine to equal negative root 3 over 2, no calculator. And then we have some with calculator. Okay, so here we go. First of all, where is the sign going to be negative? I'm going to draw a picture of this. Where am I going to have a negative sign value? Where? 4 and 3. 3 and 4. 4 and 3. And again, we just talked about it. There's no confusion about where sine is negative. Sine is y. Where is y negative? Right down there. So these are the angles we always key on. So this is opposite. This is hypotenuse. You should recognize that. If I haven't allowed a calculator, there has to be something special going on. How big is that angle? That's a 60. So this is a 60. The triangles are always congruent. But if you answer the question and say 60, you'll be wrong. Because angles don't start being measured right here. Angles start being measured right here. So the answer isn't 60, the answer is 240. And over here, the answer is
330.
Not 330. 300. Why is it 300? Because all the way around is 360 and you've missed 60 of it. So it's 300. All right, same directions, only now we have the tangent equal to 1. The tangent equals 1. All right, so start out drawing a picture of it. Where will the tangent be a positive number? Start with that. Where is tangent going to be positive? 3 and 1. 1, for sure, everything is positive in 1. Why 3? You are exactly right, but why is the tangent positive in 3? because x and y are both negative, and tangent is y over x. So if they're both negative, your tangent will be positive. Now, we want the tangent to be 1, so the picture looks like that, which means this angle is how big? 45. So is this one. The triangles are always congruent. Your angles are measured from here. So start here and go to the diagonal line. So one answer this time actually is 45, right? What's the other one? 225. 180 and an additional 45. Very, very good. All right, one more of those. No calculator. 2 cosine equals -1. So cosine is -1/2, right? Let's just solve the equation like normal. Okay? Now, I'm not going to be sitting there whispering steps in your ear when you take your test, so you got to know, what do we have to figure out here first? What quadrants? You need to draw your picture to figure out your angles, so we need to figure out what quadrants we're in. So cosine is negative. 2 and 3. One more time. Cosine is x. If you want x to be negative, then you gotta be over here. Now, cosine is adjacent over hypotenuse. Remember, we're always relative to the origin. So this is the adjacent side, opposite side hypotenuse. This triangle's gotta be special if I'm not letting you use a calculator. Is it special? Yes. How big is this angle? And so is this one. So the 2 answers to the question, neither of them 60. We start here and go to the diagonal line. So what's that one?
120.
That one's 120. And then we start here and go to this diagonal line. That one would be 240. Very good. Very, very good. Now, the only difference in problem 18 is that these guys are not going to be 30, 60, 90. So when you draw them, you're going to do all the drawing and everything the same, but the triangle is not going to be special. So we're going to have to use our calculator to figure out that angle. Okay? And I noticed that this one is set up in radians. So let's put our calculator in radians and let's do these problems in radians instead of degrees. All right, so does everybody have your calculator in radians? All right, we're not ready for it yet, but let's get it set and ready to go. Okay, so here's our equation. 3 sine minus 2 equals -3. So let's, first we just got to solve it regular. So did you get sine x equals -1/3? Okay, so everything's the same, so I need to draw it. Where am I going to draw this? 3 and 4. Very good. Sine is y, y is negative in quadrant 3 and 4. This would be the -1 and this would be the 3, right? Do you see how that's not special? That is not one of your triangles that you memorized. So that means I need to go to my calculator. I need to find the angle whose sine is 1/3. Now, for me personally, I don't type in the negative. You can if you want. With cosine, it's going to make it confusing. So I would suggest, forget the negative. You've already taken care of the negative by putting it in these quadrants. So I'm just going to type second sine 1/3. Second sine. Why am I doing second sine? Because I'm looking for an angle. And I'm going to round it off to the nearest hundredth, so it would be 0.34. So these angles are 0.34. Now, tell me how I'm going to find this angle, and be very, very careful. I was afraid of that. It's not going to be 180 plus 0.34 because 180 is a degree measure. If I'm in radians, then I'm going to add what? Not 180, but pi. So this is going to be, remember, this is pi. Half a revolution. This is 2 pi over here. So I'm going to add pi plus 0.34, which is 3.48. Now, when we were in degrees, you had no problem. You were adding 180 or subtracting from 360 or doing whatever you needed to do. This is exactly the same thing. We're just doing it in radians. So instead of using 180, you're going to use pi. And instead of using 360, you're going to use 2 pi. All right? So now I'm going to find this one. Well, 360 minus 0.34, but since we're in radians, it'll be 2 pi minus 0.34, which is 5.94. Do not be confused. You know pi is the same as 180. You've told me that a million times. You know that. So instead of using 180, use pi. Whatever you were going to do with 180. If you were going to do 180 minus, then do pi minus. All right, let's try the next one. What is it? 5 tan equals 1. All right, we're going to do all of these in radians because it's good practice for us. So 5 tan equals 1. So tan equals 1/5. Can you tell already that's not one of your special triangles? Because that would be opposite and opposite and adjacent would be 1 and 5. Those aren't our special numbers.
Will we go about it in degrees all the time unless it's specified in degrees?
You can go about it whichever one you want,
Okay.
unless the directions tell you. Yep,
Okay.
yep. Now, again, Chloe, you got to remember that as you move farther in your math career, you're going to phase out degrees. Everything is going to be done in radians. Okay? So that's kind of where we're moving. All right, so tangent equals 1/5. So we got to figure out where we're going to draw it. What would you suggest?
1 and 3.
1 and 3. Patty, does that make sense to you that I'm drawing this in 1 and 3?
It does.
Okay. Why? Because the girls said so and they're smart?
And the fact that I'm not entirely paying attention.
I know. We need to pay attention, okay. Alright, 1/5. Tangent is 1/5. Obviously, I don't have this is root 26, which is great, but I have no idea what this angle is. So I'm going to go to my calculator, I'm going to find it. And since I'm looking for an angle, I'll second tangent, right? And I got, gosh, if I round off to the nearest hundredth, would that be like 0.20? Is that what you got? So these are both 0.20, all right. Now what are my answers? That one is 0.20. And how am I going to get this one now? Pi plus 0.20. Because it's half a revolution. That's 180. That's pi. And then added 0.20. So that would be 3.34. If I added right. in here. This is a massive sheet. But the good news is, if you can do, oh, that's on 12. If you can do everything on this sheet, you are so prepared. This sheet's huge. All right, what do you think about that, okay? So we'll start by doing what? Yeah, subtracting 7, is that calculate right? Subtracting 7 and dividing by 8. So 8 cosine equals 12, and cosine equals 12/8, which reduces to 3 halves. All right, what's the next step?
Draw the picture.
Draw the picture. And which quadrants will I draw the picture in? 1 and
No.
4. 1 and 4. And I'm drawing it in 1 and 4 because cosine is x, and x is positive in 1 and 4. So adjacent, wait a minute. Does that bother anybody? The hypotenuse has to be the biggest side. This problem has no answers. It's not possible. You can't have an angle where the adjacent side is bigger than the hypotenuse. This is a cosine problem. What is the highest value of a cosine, boys and girls? 1. Can you have a cosine that's bigger than 1? Nope, not unless you put an amplitude on it, a multiplier on it. So that's impossible, no solutions. Now, that was easy. What's next? What's the period of this guy? Oh, by the way, what if that had been a sine? Could you have that triangle?
No.
No, that would be empty set also. That would be empty set also if it had been a sine problem. All right, so here we go. We've done a lot of these. I think we're ready. What's your period here for the first part? 2 pi over 2, which is pi. Good. So we got pi, 2 pi, 3 pi, 4 pi, 5 pi. Da, 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 da. What's my period here? 2 pi over 5, which is 2 pi over 5, 4 pi over 5, 6 pi over 5, 8 pi over 5, 10 pi over 5. I think I'm going to stop right there because one more time, my period turned out to be 2 pi. Sinusoidal? Nope, because the periods of the pieces did not match. Oh man, look at number 20. Oh man. Oh boy, absolute value. Oh man. This is going to require me to think back to about September.
Although this isn't that bad.
Well, it's not that bad for you. It's horrible for me because I can't remember yesterday. But let's see if we can figure this out. Do you remember back at the beginning of the year when we had these crazy pictures and I would graph something like this, and then you did stuff with it, like moved it up 1 or shifted it left 2 or whatever, right? What happened when we took the absolute value? Do you remember? Everything became positive. So the stuff that was already positive stayed positive, but the part that was negative ended up coming up. So when I take the absolute value of my sine curve, now remember, your sine curve, I'm just going to graph one period of it. Your regular sine curve looks like this. This is what you memorized. That's your regular sine curve. So when I take the absolute value of it, it's going to take this guy and pull him up, right? And then when I add 1 to it, it's going to take the whole picture and move it up 1. So this point's coming up here. And so the picture I'd be looking at would be this. That actually isn't right. Would look like this. Would you agree with me? So the question is, I'm going to go ahead and just erase this one so it doesn't confuse us. What is the period of that? Now, keep in mind, I only drew one period to start with, so this thing is going to keep going. The period is the chunk that keeps repeating itself. Well, what keeps repeating itself here?
The pi.
Just this, right? I could erase everything else, and wouldn't that be it? Wouldn't that tell me what the picture looks like? So what is the period of this? Pi. You only need this much of it to get the curve because the valleys became hills and weren't a separate part of the picture anymore. .21, I only talked about in one class because I forgot to mention it and somebody asked me about it. I don't remember if it was this class or not. When you did your homework, hopefully though you noticed, this notation is exactly the same as this notation, arc sine. Back before calculators, like in the old days when I was taking this class, this is the notation that we used. Then when calculators came along and everything became function up, everything became like functions, then they switched to the inverse notation. But these are exactly the same. So if you see arc tan, that's the same as inverse tangent. Arc, inverse, same thing. All right. Number 22, find the exact value. Now, before you start thinking, oh my gosh, why doesn't she shut up? Remember, I'm doing your homework for you. All right? So we're getting this done, and you're not going to have to do it, and this is a huge worksheet. Okay, so find the exact value. All right, what is the question asking me? Find what? What am I looking for? The angle whose tangent is -√3. Now there are rules associated with this notation, right? For the tangent, what's the rule? 1 or 4, left or right side. This is a right side function. I'm looking in quadrants 1 or 4. Since that number is negative, I am looking down here. Right? Tangent, this would be -√3 and this would be 1. This then would be 2. How big is that angle? The angle is 60, so the answer is -60. The answer is -60 degrees. All right, now we've got find the sine of the angle whose cosine is 1/3. Find the sine of the angle whose cosine is 1/3. So I'm going to draw a picture of it. This is an inverse cosine problem, so it's up here. Which quadrant am I going to draw my triangle in? 1. And cosine is 1/3. So the opposite side would be square root of 8. 9 minus 1, 2 root 2. Now that is not a special triangle, but it doesn't matter because I just need the sign. What's the sign? Opposite over hypotenuse, 2 root 2 over 3.
So we can't just leave it as square root of 8, you want us to simplify it?
Yes, of course I do. All right, and C. This one always messes us up a little bit if we can't think backwards. Think about the question Taylor just asked. She said, can I, well, no, it's not quite the same question, I guess. This one, if you drew this picture literally, you would draw this. And you would say to yourself, wait a minute, oh, that's not what you would draw. You would draw this. And you'd say, wait a minute, I don't have any triangles that have those sides. But if you think backwards, this is the simplified form of 1 over root 2. So if you think backwards, you're looking at a triangle where this is 1 and this is root 2. Now, for those of you that are thinking, there is no way, Mrs. Ford, I'm going to think backwards. I can't think forwards. Backwards is going to be impossible.
Yep.
Then you're going to go ahead and do the Pythagorean theorem and say x squared plus 2 equals 4. So x squared equals 2, and this is also root 2. And then I expect you to be smart enough to recognize, hey, I have a right triangle, 2 sides are the same. That only happens if this angle is 45. So the answer to the question is 45.
So would that be root 2 or what?
You're finding the angle. The angle is 45. The answer is 45 degrees. This notation always means find the angle. So the answer is a degrees or a radians, one or the other. Now the next one says, type it in on your calculator. Find the value with the calculator. All right? Press exactly the buttons they tell you to press. So you press tangent, second sine, 7/8, 1.8074. Is that what you got?
Yes, ma'am.
Now, you could do that problem without a calculator. We just did one. But here, that problem is just seeing if you know to press the buttons that are written on the page. And there's nothing special, fancy. You just press tangent, second sine, 7/8, and on you go. You can cross off 24. If that shows up, it's going to be a bonus question. It's not going to be a required question. Number 25, last one before the word problems. How large is an angle determined by a 2/3 clockwise rotation? So the question is, all right, here's my circle. How big is the angle determined by going 2/3 in the clockwise direction? Now you're starting here, always, and it's clockwise, which means we're going this way, which means it's going to be negative, right? That's negative. And 2/3 of a revolution. What's a revolution? In degrees? 360. So 2/3 of it would be, this is not a hard question. 2/3 of 360 is 240. So the answer would be negative 240 degrees. All right, now we got a bird in the top of a tree. looking down at a worm on the ground. I gotta get more creative. We got a lot of birds looking at worms. His angle of depression is 18 degrees 12 minutes. You can put your 1812 here or here. I'm going to put it there. I always do because I like to have it inside my triangle. So I have my bird looking down at my worm. Find the height of the tree. If the worm is 123 feet from the base of the tree. So where does 123 go?
On the bottom.
On the bottom. It's the horizontal. Because the worm is 123 feet from the base of the tree. Alright, so now we got it all set up. What function shall we use? Tangent. So we'll say the tangent of 1812 equals x over 123. So what I will type into my calculator is 123 tangent 1812. So 123, make sure I'm in degrees. I am not. Good thing I checked. That could have been disastrous. 123 tangent 18 second angle degrees, 12 second angle minutes. I got 40.44 feet. Did I do that right?
Mm-hmm.
All right. Number 2. Aubrey is walking at a pace of 3 miles an hour toward the Math Hall of Fame building. So here is the Math Hall of Fame building. Here is Aubrey. She's walking toward, I can only dream, toward the Math Hall of Fame building. At one point, her angle of elevation to the top of the building is 11 degrees. After 15 more minutes of walking, so this is 15 minutes. That is not a distance. I'm going to figure out the distance, but right now that's 15 minutes. Now she looks up and it's 13 and a half degrees. How tall is the building? Now, does that picture make sense, everyone? Okay, I got to do something here. How fast is Aubrey walking? 3 miles an hour. How long is she walking? 1/4 of an hour. Right? How far has she walked? Distance equals rate times time. How fast is she walking? 3 miles an hour. How long is she walking? 1/4 of an hour. How far has she gone?
3/4 of a mile.
Thank you so much, Maria. 3/4. I'm going to go ahead and say 0.75 because it's going to be easier for me to write my equations that way. All right? Now, we've done some like this. This is harder than the bird on the worm and stuff. This is harder. What do we have to do here? We're going to need 2 equations. So maybe we'll call this y. And one of our equations will be tan 13.5 equals x over y. Remember doing this one day?
Yes.
So I wrote a tangent equation for this one. Now I'm going to write a tangent equation for the whole one, and that will be tangent 11 equals x over y plus 0.75. So now I have 2 equations with x's and y's. So I'll figure out my substitution or elimination. So do you have an idea here? How did we do this when we did it before? We got rid of the fractions, right? So this says x equals y tan 13.5. And this says x equals y plus 0.75 times tan 11. And so once we did that, once we got the fractions gone, then we noticed that both equations were equal to x. So we could build an equation that said y tan 13.5 equals y tan 11 plus 0.75 tan 11. What did I do there? Just distributed. So I set them equal to each other and went ahead and did the distributive there. Took tan 11 times y and tan 11 times 0.75. Now do you remember what we did? We didn't factor yet. We're going to factor, but we can't factor until we have y's on the same side. So y tan 13.5 minus y tan 11. And then, Anna, you are right. Then we factored out the y. Once we got them on the same side, we factored out the y. And then got y by itself. So what is y going to end up equaling? 0.75 tan 11 divided by this big parentheses. Tan 13.5 minus tan 11. So if you type it in exactly the way I wrote it, you will be good. Watch the parentheses around the angles. You don't control those, but you have to close them. They come up. You got to close them. I got 3.19. Do I have a confirmation on that? 3.19?
Yeah.
Be careful, be careful, be careful. We just went through all that work. And we just found y. Oh gosh.
Oh no.
Do not panic. Do not panic. To get x, all you have to do is take the number on your calculator, and which is y, and times it. So say times tan 13.5, and x is 0.77 if I round off to the nearest hundredth. Now, remember I made this problem up. The unit on that is miles. So this building is 0.77 miles tall. Pretty tall. All right. We got time for one more. Yes, Olivia.
Okay, since we hopefully are gonna have one of these problems on our test, couldn't you basically just do like a shortcut where like you just multiply like the distance moved by the small angle, like then divided by like the big angle minus the small angle? Is it gonna be the same?
No. Here's the deal with that. Those things are not proportional, unfortunately, because these are not similar triangles. I think that's what you're trying to do, right? Is set up like a proportion?
No, like
Okay.
that final equation.
All right, can I talk to you after class about it? The answer is no. The answer is no. But I don't quite understand your question, so I can't explain why it's no. It would be great if it would work, but it doesn't. All right, it's why we have things like the lost signs. Those proportions just don't happen. It'd be awesome if they worked. Or maybe if you discover something, that would be awesome too, for future generations of students. All right, so here we go. Let's get one more done. We ought to be able to do this because we practiced one already. A ship sails from port So here I am at port. A ship sails on a course due north. So he's going straight up at a speed of 12 nautical miles per hour for 2 hours. So this is 24. 12 miles an hour for 2 hours. He then turns on a course due west at a speed of 13 knots for 1 hour. So that's a little bit shorter. That's 13. All right, so everybody with me? At this point, what is his distance and direction? I'm going to move the 24 over here. What is his distance and direction? Here's the direction, measured from due north, from port. Well, this is easier than the other one we did because we don't have to do any finagling. This is automatically a 90-degree angle. The Pythagorean theorem says 13 squared plus 24 squared. Yep, that'd be 169. We can go ahead and get a decimal. So about 27.29. So we're 27.29 nautical miles from port. And how am I going to find that course? I need this angle, right? And once I get it, I can subtract from 360 to get the actual direction, right? Remember, we measure from due north. That all the way around. So I'll call that angle theta. How am I going to find theta? I know it's tangent. I know the tangent of the angle is 13/24. So to find the angle, I will need my second tangent button. So second tangent, 13/24. I got 28.44. Is that okay? So what is the direction? 331.56 degrees. That's the course we would have to sail on to end up where that guy stopped. All right, so we got 2 more to go on Tuesday. Do I see you on Tuesday?
Yes.
All right, so I got 2 more to go. And then this homework will be done. So over the weekend, you might want to be working on the other 2 of these sheets. They're much shorter. One of them is called pre-test and one of them is called practice test. Those are going to be due on test day. Caitlin, can you switch that on?
Like right